In previous chapters, we talked about TCP, the Transmission Control Protocol, and then we talked about IP, the Internet Protocol. There's something called the TCP IP suite, and even though TCP and IP are the only protocols really highlighted in that name, there's actually over 500 protocols that are a part of this whole package. So it is a whole stack, or suite, as they like to call it, of different protocols. Your book mentions that there is a big movement trying to change the name to the Internet Protocol Suite. However, most exams, the CompTIA exam, at least as far as I'm aware right now, will still refer to it as the TCP IP Suite, and most people will refer to it as this. So currently, this is what it's called. We're going to go over the concept of connection-oriented and connectionless protocols again. We talked about this a little bit last week, but we're going to go over it again here in kind of a different angle overall throughout this chapter. So a connection-oriented protocol or connection-oriented communication in general, you have something like this: acknowledgement between two people, beginning the conversation, conducting the communication, and then closing out the communication. So the classic example that most people go to is something like a phone call. You don't just start talking immediately as soon as you dial. You wait to confirm that someone is on the other end. You usually do some kind of introduction, and then you begin your communication. And then when you're done with the communication, you will both indicate that you're done communicating and then hang up the phone call and close that out. So that is kind of a connection-oriented style of communication. Connectionless communication, on the other hand, there's no opening acknowledgement, there's no closing. It's sort of often the comparison for this would just be shouting something at someone across the room. Session. A session is any single communication between computers. A session must begin and must have an ending. TCP, Transmission Control Protocol. Again, this enables connection-oriented communication. We went over this a lot last week, so again, we're just going to kind of do a superficial coverage of some of this. The connection-oriented session checks for errors. Sender takes the initiative to send again if no acknowledgement is received. TCP uses a three-way handshake to establish communication. This is kind of the simple version of it, so let's go ahead and look at what's going on here. First, the client will send a segment to the server with the synchronized flag checked, and then the server will respond with the synchronized and acknowledged flags checked. And then in step 3, the client will then respond with another acknowledged segment with the acknowledgement flag checked. So that is kind of the three-way handshake. The simplest version of the three-way handshake. Again, there's a little more depth to it, and we'll cover that in later chapters. When we're using TCP, we also have a process for ending the communication. So we don't just stop talking when we're done, just like a phone call. We have a process where we let the person know that we're finished talking and we're going to end the communication and hang up. So we have something like that with TCP as well. This is a 4-step process. When the server is finished sending all the information, the last segment will contain a finish flag. This lets the client know that the server has finished sending all the information. Then the client will respond with an acknowledgement flag and a finish flag. Then the server will send one more final acknowledgement flag. Again, this is kind of a simplified version of that process, but it will do for now. We'll dig into it deeper later on. User Datagram Protocol, UDP. It's a connectionless protocol. So again, TCP is connection-oriented, UDP is connectionless. There are also a lot of other protocols or applications that are built around the UDP protocol. So we have things like DNS, DHCP, NTP, SNTP, and TFTP. We'll go ahead and cover what all of these are here in a second, and a little bit of detail on those. DNS, this stands for Domain Name System. I'm going to give you the kind of textbook definition here for it. Enables the use of names associated with IP addresses for devices connected to IP networks. So again, the short version is we swap a website's name for its IP address. Again, because it's very hard to remember a whole list of IP addresses for different websites like Google, Facebook, TikTok, MySpace, whatever you guys are into. It's hard to remember a huge list of IP addresses, but it's much easier to remember a bunch of website names. So essentially what DNS does is it allows us to enter something like google.com instead of their IP address, and it will automatically kind of swap those out for us. That's the sort of simple way of looking at that. The more important thing that we need to know here is that it uses port 53 by default. So again, DNS, Domain Name System, essentially what it does is it helps substitute names for IP addresses or IP addresses for names, and it uses port 53. Dynamic Host Configuration Protocol, DHCP. I'm going to run down the kind of textbook definition for this. Dynamic Host Configuration Protocol, DHCP, uses UDP to provide IP configuration information to clients. So again, if we were to try to manually assign IPs for every single device, it would be nearly impossible, especially if you were the network administrator for a huge company with massive office farms with hundreds and hundreds or thousands of devices. So we use something called DHCP to automatically assign IPs and IP information under certain conditions. So what DHCP does, or the Dynamic Host Configuration Protocol does, is it allows DHCP servers to give DHCP clients TCP IP configuration information. It uses port 67 and port 68. NTP and SNTP, Network Time Protocol and Simple Network Time Protocol. Again, let's hit you with the textbook definition here. Network protocol that uses UDP to synchronize the clocks of devices over packet-switched variable length data networks. That sounds like a lot. Again, the kind of simple version of that is NTP helps synchronize clocks. That's it. NTP operates in a hierarchical fashion over clock strata. NTP is one of the oldest internet protocols in current use. SNTP, that's just a kind of simple, leaner, lighter version of NTP. We're not going to focus more on that right now. Both of them, again, essentially what they do is synchronize network clocks or network device clocks. It uses port 123. Trivial File Transfer Protocol. Again, this is a protocol that transfers files between servers and clients. It uses UDP. That means we don't have any data protections. Remember when we talked about TCP IP, we talked about how we go through this whole process of securing a connection and making sure that all the information is sent and arrived accurately and intact completely. UDP, again, it's like shouting across a room and not checking or looking back to see if anyone has received the information, if it was correct, or any of that. So we just kind of blast the information out there, take it or leave it. And so we generally don't want to use this over the internet or over any type of connection where information may be lost. It's okay on a LAN or some kind of environment where we're connected directly to our server, where the chance of information being lost is fairly low. This uses port 69. Port 69. ICMP. Works at layer 3 to deliver connectionless packets. Handles low-end housekeeping tasks. So if a host is unreachable or router advertisements, it's also used for the ping command. So if you open a command prompt and type in something like pinggoogle.com, it will use ICMP to complete that process. This is just an example of using the ping utility in a command prompt. We're not going to spend a lot of time on that. I think you guys will see enough of that throughout the semester. Port number is essentially a logical connection. I like to think of it, if you wanted to connect your device like a cell phone or something like that to your computer or your laptop, you would generally plug a cable into a port on the phone and then a USB port or some kind of port on your computer, laptop, or whatever device it is. And that's how you make a connection to transfer data or information between those two devices. So a port number is kind of like that, but again, we're thinking of a logical port that we're making that connection with rather than a physical port. So again, port numbers are essentially logical connections. A port number has a 16-bit value between 0 and 65,535. Don't panic too much. The main thing that you're going to have to remember is some key ranges of ports and then a fairly small list of ports. Again, it's a little bit of brute force. It's a lot of work. Get your flashcards ready. Okay, these are some of those when I was talking about how you're going to have to memorize some broad ranges for port numbers. This is one of those big areas right here. So we have a category called well-known ports. This is 0 to 1023. This is the well-known ports range. The next range of ports is 1024 to 49,151. This is the category called registered ports. Then the last category is this right here, 49,152 to 65,535. This is dynamic, ephemeral, or private ports. So this is all this category right here. Again, the easiest way to go about doing this is just make flashcards of those and keep practicing and do a little bit of brute force memorization for this. Okay, first on the list is well-known ports. These are used by system processes that provide network services. They're ports 0 to 1023. When I pulled up, or the last time I pulled up the CompTIA Network Plus exam objectives for the N10008 exam, these were all port numbers that they highlighted, at least in the well-known ports range, that they thought you guys need to memorize. So I went ahead and put them all here. We're not going to talk about all of them today. We're going to go through and talk about a bunch of these, but I just thought it was a good time to kind of include that whole list. You may want to take a screenshot of this, write it down, memorize it. Again, you probably want to make a flashcard for each of these that you can go through and practice, or however you want to brute force practice them. Again, because you're going to need to know all of these. All of these are potential questions that you could get on the CompTIA Network Plus exam. This is the registered port section. So companies and organizations can register ports with IANA for use with applications and services. Again, this is the port range 1024 to 49,151. These are examples of different things in this range that are commonly used. So like remote desktop protocol, 3,389. Once more, you probably want to make flashcards for each of these on this list. This is the dynamic or private ports range. The nice thing about this one is you only have to remember the range. So 49,152 to 65,535. You don't have to remember a bunch of individual ports from this category. These cannot be registered with IANA. So this is the kind of easier category out of the three in the list. Using ports in a session. So when we have communication between two devices like a client and a server, both computers will keep track of the status of that communication. The session information is going to be held in memory. So we call that, when we're referring to that session information on one device, we call it a socket or an endpoint. Key parts of that session information, we're usually referring to IP plus port number as a socket. So we're talking about IP plus port number. That combination together will be referred to as a socket. When we're talking about the same session information from the client and the server, we call that a socket pair or endpoints. So this is a really good slide. I really like this topic. Connection status. If you're on a Windows machine right now, you can open a command prompt as administrator and type in the command netstat -an, and you can see a list of active connections on your device right now. You can see what protocol they're using. You can see the local address, so the IP and port number. You can see the foreign address. You can see the state, so like example, listening is waiting for something, or you have an established connection. You won't see exactly what is using it, so it's a little harder to figure out what is going on with that. However, you can use the command netstat -an ob, and then you'll get a loadout like this, where again it tells you the protocol, it tells you the local address, it tells you the foreign address, it tells you the state, so if we have an established connection ID, it tells you the PID, which is the process ID. So I think it's a really interesting way to see what's going on in your network and your device. As nice as the command line interface is, there is a better way to go about it, and that's using something like TCPView. Essentially, it's the same thing, but you get a nicer user interface that makes everything a little bit cleaner, easier to read. You can sort and filter things. So really fantastic tool, much easier to interact with. You can get it by going here. I'll drop this URL in the description of the YouTube video. This will take you to the downloads page, where there's more than just the TCPView. There's a ton of other utilities there. You can spend a little time checking those out, reading through those, and see if there's anything you're interested in. But the one you should definitely check out, again, free to use. It's from the official Microsoft Store, so nothing wrong with it. Worth checking out. In this next section, we're going to talk about some TCP IP applications. So we're going to talk about Telnet, SSH, email protocols, databases, FTP. We're going to talk about some newer stuff like the web, HTTP, HTTPS. We're going to try to get through these pretty quick. Telnet and SSH. Essentially, Telnet is a way to connect to another device or a server or some kind of client through a command line interface. One of the major problems is there is no encryption. Telnet server runs on port 23. And key emphasis, clients can connect to a server and run commands, allows remote server administration, requires username and password for security. Again, does not have any encryption, so everything is sent over plain text. SSH, very similar to Telnet, but this is just the kind of encrypted version. We have encryption and authentication. Has replaced Telnet for every serious remote access via terminal emulation. Again, Telnet port 23, SSH port 22. Electronic mail, or email, it's a major part of the internet revolution. Provides a quick way for people to communicate and send messages and attachments over the internet. There's a couple things we're going to focus on here. So we're going to talk about email clients and email servers. We're also going to talk about a bunch of email protocols. Email programs use layer 7 application protocols. So we use SMTP, POP3, and IMAP4. So SMTP is to send email only. So this doesn't do anything with receiving mail. It only deals with sending email. POP3 and IMAP4 retrieve email. So SMTP sends email, IMAP4 and POP3 retrieve email. SMTP, Simple Mail Transfer Protocol. Used to send email from clients and between email servers. SMTP travels over TCP port 25. SMTP, Simple Mail Transfer Protocol. Again, this is used to send email from clients and between email servers. We use port 25, so this will use TCP port 25 by default. IMAP4, Internet Message Access Protocol version 4. It's an alternate to POP3, retrieves email from email servers, uses TCP port 143. Supports features not supported by POP3. So again, it's an improvement in a lot of ways over POP3. These are two key features that IMAP4 supports that POP3 does not. So it enables synchronization of mail among many devices and supports the concept of folders on IMAP4 servers to organize your messages. So it supports the concept of folders and synchronization among many devices. Email servers. There's a few types, but we're only going to focus on some of the biggest ones. Like XM has 50% of the market and runs on just about everything. So you can run it on Linux or Windows. You can run it on hardware like a Raspberry Pi. It's pretty versatile, pretty compatible with a lot of things. Microsoft also has its own Microsoft Exchange server, uses both SMTP and POP3, only runs on Windows devices, so can't run on a Linux server. It uses one server package for all of this. Email client. Essentially, this is just a program or an application that runs on your computer to manage your email. Microsoft Outlook is probably one of the most popular ones available right now. Webmail. So this is probably more popular overall, I would guess, for most people. This would be something like Gmail or Yahoo Mail or Outlook, where you just go to a website like gmail.com and you log into your email and access your email from there. Some of the key benefits of web-based email services are you can access your email from anywhere. They're free. Most of them are free anyway. And they're handy for throwaway accounts. SQL. Essentially, SQL is a programming language that helps you interact with databases. A database is essentially something that will store data in an organized manner for quick research and retrieval. Database server software should be able to host database files so that people can access them directly on the network, be able to handle multiple people accessing it simultaneously, and provide data for many applications. Relational database. We store individual records in tables, and tables should be able to refer to data in other tables. Okay, the schema. Relational database schema. Essentially what this is, it describes all of the tables, the fields in each table, and how the fields in different tables relate to each other. What is a query language? Essentially, it is used to describe the bits the database server should find. Different kinds of databases sometimes need their own query language. However, structured query language, SQL, is used by almost every major relational database. This is just kind of the abridged version of what we just said there. So SQL is a standardized programming language that is used to manage relational databases and perform various operations on the data in them. These are some key ports that you need to know. Microsoft SQL Server uses ports 1433. Oracle SQL.NET uses port 1521. The open source MySQL uses port 3306. FTP. FTP is kind of an older file transfer protocol. The original file transfer protocol. Active FTP uses TCP port 20 and 21 by default. Passive FTP uses port 21. Access. So we support a couple types of access. We can support anonymous FTP sites where anyone can log in. You can also use a secure FTP site where it requires a username and a password. So we have to be careful here. The way your book describes it is a secure FTP site where you're using a username and a password, but we don't want to mix that up because it's not secure in the sense that the data is not encrypted. Data is sent in plain text when we use just FTP, where we're using plain old FTP. Data is not encrypted, so everything is transferred in plain text. So under that context, we would consider FTP to be not a secure form of communication. There are variations of the FTP protocol that are secure that use encryption. We'll talk about those later on in the semester. HTTP, Hypertext Transfer Protocol. This is the underlying protocol of the web. I'm going to say that again. This is the underlying protocol of the web. Traditionally, TCP runs on port 80. If you click up in the URL of your web browser, you're going to see something like this: http://www.example.com, or something similar to this. When you see that HTTP at the beginning, it means you're connecting to a web server using the Hypertext Transfer Protocol. Most of you, for the sites that you visit regularly, you're probably going to see a variation of this, HTTPS. We'll talk about that in a couple slides from now. HTTP defines the commands browsers and other software use. HTTP has some weaknesses, so it relays commands without reference to any other commands used previously. This makes it difficult to design complex or interactive web pages. We have a few types of technology that we use to supplement that, to make that easier, which would be JavaScript, server-side scripting, and cookies. One major drawback of HTTP is that it is not secure. So nothing is encrypted, everything is transferred in plain text, so it's easy to use something like Wireshark to capture those packets. SSL, TLS, and HTTPS. The internet has for the most part moved away from HTTP. Again, because it's not secure, everything is transferred in plain text, so it's easy for someone to intercept that communication, pick up your usernames and your passwords, or all kinds of personal information. I think the majority, last time I checked, I think over 80% of the websites out there are still using some kind of HTTP. However, almost all of the popular sites are using HTTPS. So all of your banks, Facebook, MySpace, Twitter, YouTube, pretty much most of the websites that are very, very popular are going to use this right here, HTTPS. HTTPS. This stands for Hypertext Transfer Protocol Secure. Essentially, it is just the secure version of HTTP. So again, we just see that when we tack that S on, the S at the end stands for secure. It's just the secure version of Hypertext Transfer Protocol. This next one gets a little bit tricky. There's, depending on which book you read or who you talk to, you kind of get different explanations of this. So I'll try to break it down as best I can. SSL and TLS are two different things. TLS is the updated version of SSL. TLS stands for Transport Layer Security. SSL stands for Secure Socket Layer. You will often see these used as one term together, like SSL TLS or TLS/SSL. Sometimes you will see them used interchangeably as if they're the same thing. However, generally, since TLS is the updated version of SSL, you will usually see in the real world that most web services are using TLS. So in short, while TLS is definitely the one that you're going to see probably most often in the real world, be prepared to see them used as one combo together. So again, something like this, SSL/TLS, or to be used interchangeably as though they're the same thing. HTTPS uses port 443. This is definitely a big one to memorize for sure. We did a quick ninja edit here on this slide to include an image for this last section. So oftentimes with browsers, or at least most browsers, will hide this HTTPS://www section of the URL, and you'll just get this last section like google.com. Or here we have an example of youtube.com, and they will give you a little padlock icon here in the corner that lets you know you're using HTTPS. This isn't all of the ports that you'll need to memorize for the CompTIA Network Plus, but this is, I believe, all of the ports that we covered in this chapter right here, and one kind of convenient location that you can screenshot or write down and make flashcards out of. I also want to emphasize the other strategy of simply memorizing what each of the acronyms mean. That will take you a long way to answering test questions. So again, a lot of the time the name of the acronym will point you in the right direction. So let's look at a few examples of that. FTP, file transfer protocol. What does it do? It's a protocol to transfer files, right? So just memorizing the name of it, it's practically named. It's reasonably named in a way that makes a lot of sense for what it does. There's other examples of this, like DNS, Domain Name Service, SMTP. What does that mean? Simple Mail Transfer Protocol. We have things like POP3, Post Office Protocol 3. What does that do? It's literally named the Post Office Protocol, and it does email. It's for mail delivery, right? Or mail retrieval. This isn't going to work for you in every single case, but again, it's kind of an easy way to point yourself in the right direction. You can use that information to kind of work your way through the question and figure out what the best answer probably is going to be. All right, that's all I have for you guys this week. I hope this video was informative and helpful. I hope you have a good one. Bye.